Okay, we've had a few minutes to look at these. For the 8 and 10, what's the common denominator going to be? 40. We didn't have to rename those, so I'm just going to put the common denominator up there. For 6 and 15, what's it going to be? 30. So they both go into 30. So now these other ones are a little bit trickier, so I'm going to take a little more time on those. For 3x squared and 6x to the third. Well, if I factor 3x squared, that's just 3xx. 6x to the third, that's 2 times 3. xxx. What do they have in common? A 3 and 2 x's. What does the top number need? A 2 and an x. Good. What's the bottom number need? Nothing. That has everything the top number has. So 6x to the third is my common denominator. This would just stay 5 over 6x to the third. What would I have to multiply this by? 2x. This would be 16x here. Again, we didn't have to do that part, but 6x to the third is all you had to find. Over here, 12x squared y and 18x to the third y to the fourth. If I factor the 12, I get 2 times 2 times 3. X squared is x times x and y. For 18, I get 2 times 3 times 3. X to the third is 3 x's, and y to the fourth is 4 y's. In common, they have a 2 and a 3, and 2 x's and a y. What does this top number need? It's a 3, an x, and 3 more y's. Right? What's the bottom number need? Just the 2. So 18 times 2 is 36. X to the third, y to the fourth. 12 times 3 is 36. X squared times x is x to the third. Y times 3 more y's is y to the fourth. Now I want to look at these two for a minute and find a pattern, or that least common denominator or least common multiple. If I have variables in it, does it affect the numbers? What would be the least common multiple if it was just 12 and 18? Would it be 36? Yes, it would. The variables do not affect the numbers at all. So the least common multiple for the numbers is just the least common multiple of the numbers if the variables weren't there. How about for the variables? Here we had x squared and x to the third. What did the variable end up being in our least common multiple, our least common denominator? X to the third, the bigger of the two. How about over here? We had x squared and x to the third. What was the x in our least common multiple? X to the third. We had y and y to the fourth. What was it in our least common multiple? Y to the fourth. So you can see a pattern developing here with the variables. For the variables, it ends up being just the higher of the two powers. We had y and y to the fourth, and it ended up being y to the fourth. So if I have 4x to the ninth, y to the 12th, z to the third, and 6x to the 13th, y to the 7th, z to the 5th. Without factoring here. First of all, can you tell me the least common multiple or least common denominator for 4 and 6? 12. For x, it's going to be x to the, I have 9 and 13. Which one's larger? 13. X to the 13. For y, I have 12 and 7. Which one's larger? 12. And for Z, it's going to be 5. What do you think? Let's do another one. So 5, a to the 5th, b to the 8th. 2, a to the 9th, b to the 7th. For the 5 and 2, what's the least common multiple? 10. For A, it's going to be what? 9. We have 5 and 9. The bigger power is 9. So a to the 9th. How about for B? B to the 8th. Now again, if we are stumped, we can always just factor this out. Of course, 5 doesn't factor. You have 5 A's and 8 B's. 2 doesn't factor. You have 9 A's and 7 B's, and you can, circle what they have in common and whatever, fill it in, just like we did before. But if you see the pattern, you can do it the short way, just by combining the powers, actually taking the higher power of the variable, and then finding the least common multiple for the numbers. I'm going to have you guys try 1 or 2 in your notes here. See if you can make this work. Have you tried that one? And I'm going to have you try this one. Try the 2 of those in your notes. See what you come up with. So for the top one, what do you get for the numbers? Perfect. 24 for the numbers. X has the highest power of 7. Y has a higher power of 8. And Z has the largest power of 9. Perfect. How about for 3 and 5? 15 for 3 and 5. A to the 11th is the larger power, and B to the 8th. Perfect. Anybody have any questions? Okay. Let's look then at our next step, which is going to be something like this. Actually, I'm going to take away the 3 for now, make it a little simpler on us. X to the 5th to the 3rd power, we've looked at something like this. That is saying x to the 3rd times x to the 3rd times x to the 3rd, right? Not x to the 3rd, I don't know got that. How about I try that again? X to the 5th times x to the 5th times x to the 5th, right? X to the 5th times itself 3 times. Or 5x's, another 5x's, and another 5x's, all multiplied together. How many total x's are there? 15. So x to the 15th. Do you guys remember the rule when you have a power to another power? You multiply. 5 times 3 makes 15. So if I have y to the 7th, the power of 11, what's that going to become? Y to the 77. Good. 7 times 11 is 77. If I have more than one variable in there, just like I do in multiplying or dividing, I can take them separately. So I have x to the 8th, y to the 5th, to the power of 3. I'm going to get x to the 24. 8 times 3 is 24. And y to the 15th. 5 times 3 is 15. Now we can slip a number in there. 5 to the 4th. Now I have to do the number, actually does have to be the power. I can't just do 5 times 4 because it's not multiplying. It is still a power. So that is 5 to the 4th, which is 5 times 5 times 5 times 5, which is 625. What happens with the A? Careful. 32, there you go. 8 times 4 makes 32. So A to the 32, B to the 12. 3 times 4 makes 12. So 625, A to the 32, B to the 12. Try this one. So we do 2 to the 9th power, which is 512. Good. X to the 99. Y to the 63rd. And B to the 72nd. Good. So we can take a number to a power, or a variable, algebraic number to a power. So now let's take a fraction to a power. 2/5 to the 3rd power means 2/5 times 2/5 times 2/5. Well, when we multiply, we're just going to multiply across the numerators and then multiply across the denominators. 2 times 2 times 2 makes 8. 5 times 5 times 5 makes 125. But more importantly, 2 times 2 times 2 is just 2 to the 3rd power. 5 times 5 times 5 is just 5 to the 3rd power, isn't it? Anytime we do a fraction to a power, we can actually split it up. 2/5 to the power of 3 really is just 2 to the power of 3 over 5 to the power of 3. So if I have 3/8 power of 4, I treat that as 3 to the power of 4 over 8 to the power of 4. 3 to the power of 4, 3 times 3 times 3 times 3 is 81. So I don't want to put the 1 like that. 81. 8 to the power of 4 is 4,096. Now here's a good question for you. Can I reduce that? No. If we look at it, can 3/8 be reduced? No, it can't, right? 3 only divides by 3, and the 8 only divides by 2s and 4s. So if I can't reduce this, I can't reduce that, because the top is all going to be factors of 3. Only the factors that are in this number are going to be the factors of this number, just repeated more often. The same here, the factors in this number will be the factors of this number, just repeated more often. If I couldn't cancel out any factors here, no new factors are going to appear over here. It's just the ones that are there are going to be repeated more often. So, something like this. I can split that up to be 5x to the 8th to the power of 3 over 6 y to the 5th z to the 3rd to the power of 3. So now what? What's 5 to the power of 3? 125. X to the 24. On bottom, 6 to the power of 3. 216. Y to the 15, and z to the 9. Perfect. Time for you guys to try one. Try that one in your notes. So again, we split this up, so it's 2a to the 8th, b to the 7th, to the 4th power, over 5c to the 9th to the 4th power. On top, what's 2 to the 4th power? 16. A to the 32nd, b to the 28th. On bottom, 5 to the 4th power. 625, and c to the 36. What do you guys think? Not bad? Well, then let's step back and review just a touch. Reduce that fraction for me in your notes. Need another minute? Look at the numbers. If we separate out the 18 and the 30, what can both of those be divided by? 6. 18 divided by 6 is 3. 30 divided by 6 is 5. So for the numbers, we have 3 over 5. The x is going to go top or bottom? Top, because the larger power of x is on top. What's the power going to be? 3. 9 minus 6 is 3. Is the y going to go on top or bottom? Bottom, because the larger power of y is on the bottom. What's its power going to be? 4, because 7 minus 3 is 4. Where's the z going to go? Bottom, because the larger power is on bottom. What's its power going to be? 1 or just z, because this is a 1. 2 minus 1 is 1. So z to the 1 or just z. How many had that right? Cool. Anybody have any questions? There's a new quiz due for tomorrow. That's Wednesday at 11:59 p.m. There's new homework. Due for Thursday's class. As always, you're welcome to stick around and work in the computer lab. I will be here till 5:20 to help you out if you have any questions. The test due back, preferably if you have it back by the end of this week, but I'll give you more time if you need it. Generally, by the next unit test, I'll cut you off.